My name is Lewis Robinson. This is my final project for Harvard Extension School, CSCIE 89. The topic of my project is video classification with YouTube. So, my problem statement is that humans do not have the time to accurately classify videos on the internet for research or even viewing purposes. It is possible to classify videos accurately with image and audio recognition techniques in the domain of deep learning. So we can use a convolutional neural network to categorize and classify the images extracted from the frames in the videos, and we can use natural language processing techniques to classify possibly speech or even music or other sounds, like, for instance, the noise of a car, found in a video, or found in the audio track of a video. So my technology stack is Windows 10, Python 3.63, again, Anaconda 3.5, TensorFlow for CPU 1.21, Keras 2.15, PyTube 922, Pandas 0.220, Pillow 5.0, and not shown in here is I'm also using OpenCV. So let's get down to business. So the data I'm going to describe is I used a YouTube bounding box data set from Google Research, and let me get to the bottom of it. This data set is rather huge. Dealing with Google, they're always doing big data. So, well, it's not huge for Google's sake, but it's gigantic for the scope of this class and even this project. What I mean is that this is the final entry in the training portion of the data set, and there are 40,576 entries in here. So what does that mean? That means that this is a data set with information about over 1 million YouTube videos. And what I'm showing right here is an actual video ID that you can put on the end of a YouTube link. Let me demonstrate that for you. Copy this, and I will put it right here. Well, and this actually comes up with a YouTube video. I guess it's a YouTube video of a toilet, and that was in the data set. So, yeah. Okay. So moving forward. What I did was I cut the data set from over 1 million rows to 2,300 rows, and that's still a lot. It's still way too much, because the data that's generated from one of these videos can be over 100 megabytes. When you download the video can be anywhere from 3 megabytes in MPEG Layer 4 to over 100 megabytes if you have a lot of frames in it. The video is going to take up space, but the frames are actually going to be they're actually going to take up a lot more space in the video. So the installation I did was I have a link here. It's in the project. You can go to just thirstapp.io/environment_setup.docx. You can go to that link, and that is the description of my environment setup. So let's go through the code here. So what I did was I I just had like the original way I wanted to tackle this problem, which is not how it ended up because it's really huge in the scope of this class. So import PyTube, which is a Python library that enables you to programmatically download YouTube videos. I'm using Pandas to deal with the CSV, which I have here, and I was going to use random to shuffle the data set, but I ended up just taking it, just using the data set as it is. So I'm incorporating the pandas read underscore CSV object, and I'm reading it in, creating headers right here. This is just a printout of the table that's generated from that panda statement. Okay, so I'm gonna start this project. I've been running it. And there's where I import, right here is where I import OpenCV, Pillow, they can call it operating system, gzip, and IO. And this is a method that I set up to deal with Unicode issues that I was getting from dealing with the actual titles, which were in foreign languages like Mandarin or Japanese, Hebrew, Greek. The umlaut and special characters in Unicode would throw off the program and create errors when I try to write files. So I set up that, but now I'm not using the YouTube titles to create directories and write files anymore. So now I'm so this is just an example I have in here. I didn't remove it. And now I'm to the actual portion of the project where I'm going to begin a loop to download multiple videos in a data set of YouTube, in the YouTube data set. But what I did was I limited the amount of videos I would download because the videos each take up, maybe 100 megabytes when you deal with the amount of frames and the amount of storage space that the frames will take up. Like the particular video I'm going to download has 5,000 frames. So let me start this right now because it's going to take a while to download. And then the video itself is, I think, 27 megabytes, something like that. I'm going to go ahead and start all of this and just run it, and just get it to run. And I will describe the rest of the code base that I have. So here I'm just setting up classes. I have cat, dog, person, boat, knife, toilet, and these are classes that were that I actually got from the YouTube or the Google Research data set, the Bounty Box data set from YouTube. Umbrella, skateboard, train, car, bird, and none. I guess if the object is identified, is unidentified. And I'm right here. I have the test portion. I'm testing. And then I am setting up, I'm writing the output files for the individual frames that I have. And I have, I have a training, validation, and a test folder for each frame, or for each type of frames, and the code writes to their respective folders. Okay, so moving forward, I'm gonna have to activate all of this because I'm waiting on that piece of code to finish running. Okay, so here's where I get into the actual deep learning portion. I'm just importing, from Keras, import layers, models, regularizers, and I'm setting up a 2D convnet, max pooling, 2D, flatten the image, do ReLU, use the ReLU activation function for dense. It's just like the homework I'm using. Also, sigmoid activation function, and then set up the model summary. Waiting for that to complete running. And here's where I feed all the frames, all the resized frames from the data set into Keras. So here's where I set up the batch. And then I'm using just the basic code to set up the history, and also, well, I need to change this because it's only, well, that's 5 epics. I'll just do that for the sake of the video. It's going to be really short, but really it was supposed to be 100, but it was going to run really long. So here's where I'm saving my model. So let's go ahead and activate that. And I'm running a second pre-processing portion where I'm using the images, and I'm feeding that to another model. So let's see. Okay, so what happened here, the video actually downloaded, and I know that because there it is. This is the MPEG. The YouTube video downloads as an MP4. I don't know what they're stored on YouTube anymore. There used to be FLVs, but now I guess they may be MP4s, whatever. Okay, so the code wrote to the image folder, and let's see, let's count. So I baked the frame count number into the actual name of the file. So this is frame 60, and let's go all the way down to the bottom. Oh, yep, 5,302 images. Yeah, there it is, right there, 5308. Okay, so now we know that the code actually works. It extracts the frames out of the video, and let's check the YouTube video to make sure that it actually, okay. So these are the frames that were extracted from this YouTube video. Here you go. Yeah, I guess it's just a concert of some sort. I don't know. I've never seen this video. I've been watching YouTube for years and I've never seen this thing. Let's pause that and go back here. So what I did was I set up a directory on here called resized, and the code also creates another directory called video with the frame count, with the video number on the end of it. So it's video 0, that's the iteration. Start from a zero index like we always do in computer science. And then I have the resized images, which are 150 pixels by 150, you can see right there. And this was done while I was speaking. So let's go down here. Well, failed. Okay, here's 5,303 items. So yeah, there you go. That's the last image. So it wrote all these images very fast. Let's see where I am in terms of. Okay, so all these. What's going on here? Oh, okay, yeah. So I ran this before. Let's see, image train. Where's the train directory? Oh, cannot create a file. Output. Image output train. Let's go in there. Oh. Yeah, I forgot all this was here, but I set it up a little while ago. Okay. That works. And this is going to take a little while. I'm going over the 15-minute mark, but this is a lot of coding I had to do, a lot of files that I had to work with to get to this point. This thing is horribly inaccurate, but I'll get there. Okay, so as you can see, it's working, it's running. I'm getting a lot of losses, 0% accurate. But yeah, I'm feeding everything through the convolutional neural network, and that is my project. Thank you for watching. Okay, so there's the end. So whenever this finishes, it'll generate. But I have the graphs and data set stored to the project folder. So there it is. But yeah.